At Lauren Concrete, we have a very extensive service area across Central Texas. We have 26 plants, one as far west as Mason and one as far east as Prairie View. Each plant has different material costs associated with them for the same item. So this means that if two plants are equidistant from a certain job delivery location, one plant might be the more cost effective option to service that job because the material costs are going to be lower. So we wanted to know for each of our plants, what is that plant's low cost service area? What is the geographic region around that plant where that plant is going to be the most cost effective option to ship concrete? And are we taking advantage of that? And as a secondary question, we wanted to know overall in the Central Texas area, what areas are going to be most costly to deliver to, and which of our customers are pouring in those areas. To solve this problem, I used eSpatial to process geographic data from each ticket that we cut in the past year. So for hundreds of thousands of records, I calculated the lowest possible material and delivery cost and what plant would provide that cost. I then uploaded all of those records into eSpatial and used the style function to color code different points based on what their low cost delivery plant would be. And then I drew polygons around each of those colored areas to mark what a plant's low cost service area would be. So this gave us some really surprising results. Some of the plants had much more limited delivery areas, low cost delivery areas than we had anticipated, and some were a lot more extensive. So this really shook up the assumption that a lot of people have that the 10 or 15 miles around a particular plant is going to be best serviced by that plant. Sometimes it's a plant that is actually further away but has lower material costs. eSpatial also helped us a lot here by making this kind of counterintuitive information easily digestible by leaders in our organization. I was able to share these color-coded maps with our leadership team and show them, hey, these areas are actually a lot bigger for this plant than this plant because of the material costs. So it helped us convey a pretty complicated idea to a much wider audience. Once we had identified a plant's low-cost service area, we were able to see what tickets had actually been shipped by a plant that had higher material cost and identify how frequently that was happening. We were able to export those particular points out of eSpatial and then sum the difference between the actual ship plant cost and the low-cost ship plant cost. And those potential savings actually added up to about 1.7 million. So that gave us a lot of insight. And we also were able to carve out overall the areas that were going to have high delivery and material costs no matter what plant was shipping them. We could also export the customers that were pouring in those areas and then reconfigure their prices based on the more expensive material costs that it would take to service those areas. We also were able to see, okay, what plants have those more limited service areas and what can we do about that? So we could look for new material suppliers to lower their material costs and expand their service areas. So without eSpatial, we wouldn't have been able to understand the reality of the effects of the differential material costs. And it helped us change the way that we think about a plant's particular territory and what plant is going to be the most cost effective to ship to a particular geographic point.